So next lecture on this segment for CS452 is basically Bluetooth, and I am going to talk about Bluetooth. So let's start. Bluetooth basically is a wireless technology, wireless LAN technology. It is a data link layer technology which actually talks about small connectivity. It's called ad hoc network. So Bluetooth will create a ad hoc network, ad hoc LAN. Now basically we can have two types of network. One is piconet, one is scatternet. So the main topics to be discussed in this particular section will be architecture of Bluetooth, Bluetooth layer, baseband layer, L2 cap. So what Bluetooth is basically, Bluetooth has several applications. We can create Bluetooth LAN. It's a architecture for designing a small scale network which is called personal area network. So basically if you look into Bluetooth project, the king of Denmark, Harald Blatant, actually is the name behind this particular technology, Bluetooth. So Bluetooth was a SIG, social innovative group of different companies started this project, and when Harold Blatant name was referred, so this Blatant was actually translated to in English as Bluetooth. So it originally started by a company which is Ericsson company. Now small devices like mobile phone, PDA, notebook computer, other peripherals use this particular technology that is called Bluetooth. It operates with a bandwidth of with a band of 2.45 gigahertz, and this is having the license of Bluetooth. It usually works in that particular area of 10 meter. So it creates a personal area network which is having 10 meters of area. Still date you can see that Bluetooth used in different devices, in card audio, Bluetooth audio, and lot many devices are there. We have version 2 which provide the speed up to 2.1 Mbps. Now this is the basic of Bluetooth, which we have already talked about this creation of Bluetooth architecture. So it got some development standard, and this SIG was initially created by Ericsson, IBM, Intel, Nokia, and Toshiba. In the year 1999, Bluetooth was started, and then IEEE gave a standard notification, and it has IEEE 802.15 notification, and this comes under IEEE 802.15. So Bluetooth is basically a LAN standard which talks about PAN, personal area network. Now Bluetooth has its special interest group, so Bluetooth SIG, who define all those profiles and other things. Now when we talk about Bluetooth architecture, we have already mentioned, we talk about piconet and scatternet. If you look into the architecture, when we talk about Bluetooth in details, it has Bluetooth piconet and scatternet. For example, if we are creating a small network with devices, this is a master, this is called slave. Now when you have such master slave connection, this is called piconet. So this is called piconet. So when we talk about this, we will be talking about this in later. Now Bluetooth piconet has up to 7 slave devices connected, and remaining devices. So Bluetooth in architecture can have up to 255 devices, but slave has two modes. One is called part mode, one is called active mode. So basically there are two modes. So only master and active slave can communicate with each other. So it's a When it is parked, it will be very low power state. Otherwise, Bluetooth is always a low power connectivity. So when we talk about Bluetooth architecture, we have something called small radio cell, which is called piconet, which is about 110 meters. And if we actually bridge together or club together with multiple piconets, then we can have called scatternet. So scatternet is basically, if we talk about piconet, so for example, this is a piconet, this is a piconet, this is a piconet. So when these different piconets are connected with each other, this becomes scatternet. Now we'll show it to you later. Now this is all about. Now master will involve into parking of all inactive and active Bluetooth devices. So you can see this is a Bluetooth network, this is a Bluetooth piconet. So these are different slaves. So when in this topology, in this pan topology, these slaves are directly connected to this particular master and remaining are in park state. Now if this device is trying to get connected, since this is not, these are not this master is not being occupied by all 7 Bluetooth slaves, so still this can actually create a connection with this particular master. So what it has to do, this particular slave has to send a request to a master, and then there can be pairing and other things can be done. So in Bluetooth architecture, master does all the control, and slave can also only be connected with that. So there is a chip which are incorporated in different devices, and then this gets Bluetooth connectivity. So there are either master slave or slave master connectivity. There is no slave to slave connectivity, and this uses time division multiplexing for connections in between different devices. So we can see there are, in Bluetooth architecture, there are 3 classes of radios which is having means depending on chip, there are class 1, class 2 and class 3 radios, and depending on that it has the range. So class 1 radio is a better, which is having 300 feet or 100 meter of range. We normally have seen there are devices, or we normally can see class 2 radio devices which is of 10 meter or 30 feet, but class 3 radio is also available, which is of 1 meter or 3 feet, which is available. Now Bluetooth architecture, when we talk about Bluetooth architecture, we have already talked about this. We have already mentioned that Bluetooth uses a 2.4 gigahertz ISM band, and it uses FHSS. Yesterday or in previous class we have already discussed what is FHSS. So this is the specification, and in such cases 79 channels with 1 megahertz each can be connected with the FSK modulations. Now this is all about a Bluetooth architecture. If you look into this architecture, so what happens, this particular slave is connected to master, this particular master is connected to another slave. So for example, this is piconet 1, P1, and this slave also can be connected to another master, and this slave is called bridge. This is actually doing a bridging in between 2 piconets. So if you look into such architecture, this is P1 and this is P2. So this actually creates a connection in scatternet, and this is actually creating a connection in scatternet. So let's go back to the slide and see. Now in this case, this particular slave is creating connection with this master and this master. So this is called bridge slave, and this creates, so such small piconets can be connected and give a scatternet. So piconet can have up to 8 stations. So beyond that, such small piconets can be connected and can create a scatternet. In that case, this master can talk to this particular master with this particular slave, where this called a bridge slave. So what is piconet? Piconet, it can have a small network which is having 8 station. 8 station means, if you look into this, there are stations which are parked, there are stations which are active. So there can be have 8 active station, out of which one station is always primary and rest are secondary. Now communications in Piconet can be one to one, one to many. So any addition to this 8 secondaries are actually in park state. So this park state also have different architecture for different synchronization. So this is a basically architecture of Piconet. So now we have already discussed about scatternet. Now scatternet, what happens? Small Piconets can be connected to different small Piconets can be connected with each other using that bridging slave. Now a station in such cases can be member of 2 Piconets, and this formation of small Piconets when gathered together, then there is a formation of scatternet. Now this you can see, this can be primary and secondary for different networks. So this can be primary for this, and this can be secondary for this. Depending on that, we can have different network structures. Now this is about different topologies. Now how Bluetooth works? So if you look into Bluetooth, so Bluetooth also, this is physical layer. We know this is data link layer. So when we look into such layer, this is data link layer. So we have a MAC layer. So Bluetooth, this Bluetooth works here. So we need to know the architecture behind this. So let's discuss in details. This is the application. So in between we have these 3 layers: radio layer, baseband layer, and we'll discuss about L2 cap. So this has different features. This each and every layer has different features. Now if you look into the Bluetooth protocol stack, so protocol stack has first radio layer. So now what is radio layer? Radio layer discuss about the band. So let's first talk about the radio layer. Now when we talk about radio layer, we have something called band. So the operating band, we already know that it works on 2.4 gigahertz ISM band. So this band is divided into 79 channels of 1 megahertz each. So this radio channel is helping physical layer to give a connectivity. Now if we have 79 channel of 1 megahertz each, so this 2.4 gigahertz ISM, the entire bandwidth will be divided into different other bands. So we will discuss this other layers now. This is basically we talked about radio layer. So this is basically comes under the physical layer part of Bluetooth. So after that, next is called baseband layer. So now when we talk about band, here comes the bandwidth that we have already discussed, that is 2.4 gigahertz ISM band. Now which frequency it uses? It uses FHSS. If you cannot remember, let me write it down. Frequency hopping. The full form of is frequency hopping spread spectrum. So this is the full form of this. Now Bluetooth has hopping of 1600 times of hop per second. So this is 1600 per second. This is the hop count of Bluetooth. Now which means there is a frequency of 1600 times per second. So if you calculate this, let's understand this in details. If you calculate this now, so we can get the frequency. If we calculate frequency is 1 by t. Now time period is 1600, so 1 by 1600, sorry, let's erase one more 0. So if you calculate 1 by 1600. So we have already seen there is a calculation that in a second it can have 1600 times of hop. So this will 1 by 1600 second. This will come to 625 microsecond. If you calculate by calculator, this will come. So the time we can calculate. So sorry, I just wrote something wrong. This is we got the frequency. So this is time period. So the formula what we wrote is little incorrect. So in this case, we actually are calculating time period t equal to 1 by f. So t equal to 1 by f or f equal to 1 by t is okay. So we know the frequency, that is 1600 times per second. So if you calculate the time period, now we got the time period, that is 625 microsecond. So this is the time period of this particular frequency. So we can calculate the other factors. If we have some calculations which we'll discuss later, we can calculate different things. So in baseband layer, we have the different access method. So the link manager will decide upon the access method. So here in this case, it uses the access method, which is called TDMA, time division multiplexing access. So TDMA is time division multiplex access. So it has two types of communication. So these two communications are single secondary communication and multiple secondary communication, which we will discuss later. Now here in this case, the physical link has two types of links. One is called that within primary and secondary, in link manager will decide what type of links can be there in data link layer. These two types of links are called SCO link and ACL link. SCO link is basically synchronous connection oriented link, whereas ACL is asynchronous current connection oriented link. Then we will discuss about L2 cap and other things. So HCI plays a huge role, that is called host controller interface in such cases. Now, so Bluetooth radio layer we have already discussed. So let me give you a brief. The radio layer moves the bit from master to slave and slave to master. There is no slave to slave communication. So there is a 10 meter of operating normally in Bluetooth radio layer, and it has 2.4 gigahertz of ISM bandwidth. The band is divided into 79 channel of 1 megahertz each, and we have seen the hops are calculated 623 to 625 microsecond. That we have already calculated. So it uses 802.11 architecture, but normally it comes under Bluetooth comes under 802.15, and these are the Bluetooth radio layer specification. Now next is baseband layer. The next layer we have seen is baseband layer. Already we have discussed. So this uses TDMA for communication, and each frame is transmitted over a logical channel is called link, and there is a link management which happens to be there with if you look into this link manager. So this link manager decide upon two different links. One is called SCO link, one is called ACL link, that we will discuss. Now this ACL link, what it is? ACL link is called asynchronous connectionless link. So what if this link is basically this ACL link is used when data integrity is more important and we need to avoid some latency. This type of link, if a payload encapsulated, then the frame is found to be corrupted. So this need to be retransmitted. So it uses packet switch network and data available at very irregular intervals, and this traffic is basically a best effort basis traffic. And ACL frame uses an odd number slot, and if we have more number of slot, it can achieve a maximum data rate up to 721 kbps. And because of the frame format, if I show you the calculation, you can understand it better. So let's go back to calculation part. So for example, I am giving a frame which is transmitting, okay, can be either one slot communication, sorry, either one slot communication or three slot communication or five slot communication, like many communications can be there. So let's take an example. A slot, per slot it is always 625. So one slot time frame is 625 microsecond. Now what happens that we have to find out the effective communication, because for example it is using a Bluetooth is using, this is for example master, this is for example slave, this is using for example three slots, slot 1, slot 2, slot 3. Now there is a frame exchange time, so we can calculate the effective time. For example, a slot is getting total of 625 microsecond. So in from link management we have to first calculate how much is basically needed for hopping and control management. So if hopping and control management takes a time of for example taking a time of 259 microseconds, so effective time in such case will be, so if you calculate effective time in such case will be 625 minus 259, which is somewhere in between exactly it will be 366. So in such cases, in this particular fashion we can calculate other things also. For example, if we talk about three slot which we have shown you in the picture, if you calculate it for three slot, for example we are calculating for three slot which we have shown, slot 1, 2, 3. Now what happens, we have seen per slot calculation, so it will be 3 into 625 minus 259, but we have calculated it will come under 1616 µs. Now in 1 µs, if I can transfer 1 bit, so total I can transfer 1616 bit. So this much bit of communication can be there. So like that we can calculate different frames and frame formats and other things. Now let's come back to the slide again. Now we have second types of communication, which is called SCO, that is synchronous connection oriented. So basically asynchronous means okay, there can be a simultaneous process, but synchronous means it is okay one after another, so it utilizes the entire channel. So SCO is used when avoiding latency, and it more important that there should be error free delivery. So SCO is used for real time audio, so it can create okay different link for different channel, but one channel is not divided into different slots. So this is slot wise, this is one single channel, this type of channel using a fixed slot for in unidirection way for communication. So now next and the most important of Bluetooth is basically is called L2 cap. So L2 cap is basically, the full form of L2 cap is called logical link control and adaptation protocol. The full form of this, we will talk about this, logical link control and adaptation protocol. Now, normally what happens in data link layer, we got two sublayer. One is called MAC and one is called LLC. So basically, the task which is being performed by this layer, that is L2 cap, the full form of this is L2 cap, is basically job of LLC. So L2 means logical link. So its full form of this is logical link control and adaptation protocol. Now it is used for data exchange for normally on ACN link and so ACL uses this LLC, whereas SCO doesn't use this LLC. So SCO doesn't use. So basically, is it's for asynchronous. When we require a synchronous communication, we does not require any support from LLC. So what happens? 16-bit length field, which defines different. Okay, let's come back to let's come back and find out. So this is basically 16-bit length of L2 cap, which has a length of 2 byte. So this basically defines, okay, the length of the data. Then after that we have channel ID, which defines a unique identifier of different channels, virtual channels, and L2 cap has some specific duties of multiplexing, segmentation, reassembly, QoS and group management, and it do data and control both. It has multiplexing, segmentation, reassembly, QoS and group management, which you all have studied in the previous semester. So this basically is done by Bluetooth L2 cap layer. Now coming back to these two things, which is there by Bluetooth baseband layer. Baseband layer is basically handle two things, that is single secondary communication and multiple secondary communication. This is a picture, but we have already discussed. Now coming to the frame format of Bluetooth, let's discuss the frame format of Bluetooth. So if you talk about frame format of Bluetooth, this is the frame format. It got the frame header. This frame header contains, okay, 54-bit field, which is a repeated 18-bit pattern. So this has the specification. So header has address type, then FAS, then HEC, and after that there is a data. So basically, it frame format, there are three things. One is called access port, then header and data. So if you look into this, there are three parts. If you look into the header part has first address, which is 3-bit address. What does this address do? This 3-bit address will define, okay, now since this is 3-bit, it has the values 0 to 7. I will take 1 to 7 because 0 means this is used for broadcast communication. Otherwise, it will define 1 to 7 channel or all different secondary channel. Now type, we know that is a type definition always. Type of the packet. This is again 4-bit field. This defines. Now F is basically to identify flow control. A is to identify the acknowledgement. S is the sequence number. This FAS is very much important. So this is 1 bit. So this FAS is basically flow control, acknowledgement and sequence number, and HEC is basically doing the header error correction. So this is basically a huge format, and this is of Bluetooth, which basically controls everything. Now we have already discussed L2 cap. We have already now discussed Bluetooth frame structure, and let's come to the Bluetooth applications. Now, when we talk about Bluetooth applications, these are the different types of applications. We have seen car audio, Bluetooth, different devices, communications. You can transfer file, audio, video, everything with Bluetooth. But it's a low personal area networks. So that's end of lecture of today all about Bluetooth. So in a nutshell, what we have discussed in Bluetooth is basically what Bluetooth is, what is architecture of Bluetooth, what are the different applications of Bluetooth, and all. Okay, thank you. Thank you for listening the lecture.